This is our first video for the year in AP Biology. Throughout the year, I'll make videos like this to help introduce topics. That way, we can spend most of our class time practicing together rather than just listening to me lecturing. Also, this video will be here in case you need to see it again later on, so let's get on with it. This is video 1.1 on organizing experiments. The goal of this video is to cover these 4 course objectives. Even though this should be review, I don't expect you to have mastered this yet. We'll work some more examples in class together. One type of variable that every experiment has is the independent variable. You'll notice that I replaced the I in independent variable with a number 1. That's because this change will help you remember the definition of independent variable. The independent variable is the one condition that's changed between the control group and experimental group in an experiment. In other words, the independent variable is the one condition being tested in the experiment. Well, let's look at this example to make it more clear. You can see that setup A, B, and C all have plants in pots. The scientist is trying to determine what liquid can make the plants grow the tallest. In this experiment, the one condition changing between setup A, B, and C is the liquid given to the plants. That makes the independent variable for this example experiment the water versus the juice versus the cola. Next is the dependent variable. I've underlined the letter D to remind us of this definition. The dependent variable is the data being collected in an experiment. In other words, what is being observed or measured once the experiment gets going. Data can be qualitative, where the data is characterized by words, or quantitative, where the data is numbers. For the most part, quantitative data is preferred by scientists over qualitative data. When you think of the dependent variable, it's important to be really specific. So again, think about our example. What's being measured about the plants? Specifically, the dependent variable is the height of the plant. It would be less helpful to say the size of the plants, because size can mean a whole bunch of different things. How much does this plant weigh? How wide is it? Things like that. But by saying height, you're being really specific. So one way that helps me be specific is to think about the measuring tool and units that you need to use to collect the data. In this case, the measuring tool of a ruler is being used to measure the height of a plant, probably in centimeters. Up next are constants. I've underlined the letter S in constants to help you remember the definition. Think of the S as standing for same. Constants are conditions in an experiment that are carefully kept the same between the different setups. Constants are super important because constants build confidence that any change in the dependent variable you're measuring is caused by the independent variable only. If there are a bunch of changes between different setups, you wouldn't know which one of the changes caused an increase or decrease in your dependent variable. In AP Biology, it's important to identify at least 3 constants that we should keep the same in an experiment. Let's check out this example again. So we can kind of imagine some constants and see some that are there. So it looks like these scientists use the same size pot and probably with the same volume of soil in the pot. And maybe the source of the soil was the same, or the mix of the soil was the same. Looks like they used the same species of the plant, so plant species is a constant. And hopefully the plants are receiving the same volume of liquid being watered at the same time of day. Whole bunch of constants. Finally, we have the control group. The control group is used as a comparison in an experiment. A good example of a control group is a group that doesn't receive a treatment or independent variable. So, for example, if you wanted to see how a medicine works, you give the medicine to some people, and then you compare that group to a control group that doesn't receive the medicine. Other times, though, a control group can just be a set of normal conditions. Then the experimental groups get changes or different levels of the amount of independent variable. So in the example below, the control group is the plant receiving water. Giving a plant water is normal conditions. You can't give a plant no liquid because then the plant would die. So that makes the groups receiving cola or juice the experimental groups. There are just a couple more things that we need to make sure we're on the same page with. That's writing scientific questions, writing hypotheses, and writing null hypotheses. Sometimes these formats can be a little bit awkward, but that's okay. Scientists like to be really organized and stick to a format, and sometimes that's at the expense of sounding really smooth. A simple way of writing a scientific question is using the format, what is the effect of blank on blank, where the first format is the independent variable and the second blank is the dependent variable. A hypothesis and a null hypothesis are pretty similar, whereas the format is if blank, then blank, if blank, then blank, where the first blank is the independent variable and the second blank is the dependent variable. Again, if you think about that I in independent variable as a number 1, that's another clue to tell you that the independent variable goes first. I want to review what a hypothesis and a null hypothesis are. A hypothesis is a testable prediction. So for this example, a good hypothesis in the if-then format would be, if I give plants different liquids, then juice will make the plant grow tallest. That's testable, and it's a prediction. Something that's not testable would be, if I give the plants different liquids, then juice will make the plants best. How do you measure best? That's not really testable. A null hypothesis is still like a hypothesis in that it's a testable prediction, but a null hypothesis predicts that there will be no change or no difference in the dependent variable from changing the independent variable. Null hypothesis is a lot simpler than you think. So in this example, if I give plants water, juice, or cola, then there will be no difference in the height of plants. That's the null hypothesis. Null hypothesis becomes more useful a little bit later. So let's recap. Experimental design is pretty universal worldwide and among scientists. So it's really important to get this straight and to make sure that we have a solid foundation when we evaluate experiments and design experiments of our own. First, clear variables and constants make an experiment easier to set up and make somebody else's experiment easier to understand. If you have a controlled experiment with a control group for comparison, that gives you confidence that differences in data between groups are due to a change in the independent variable, and it's not hard to pick out which change in the independent variable caused a difference in the data. Finally, the reason that we invest all of this time in these universal formats is because these universal formats help keep our thinking organized for ourselves and for other scientists.